complex number, this is another definition for us. A complex number is a number a plus bi. You know, this is a whole, it's basically a binomial. A plus bi. The a is the real part. That is, it's a real number. It's not an imaginary number, like it doesn't have I in it. And the bi is the imaginary part, called the imaginary part because it's the part that has I. I is a lot like x in some ways, in that if two terms don't contain I, they can't be combined together. All right, like terms have to be combined with like terms. That's a normal rule. We're used to that. So when we add or subtract, if we want to add or subtract two complex numbers, we have to add the real parts, and we have to add the imaginary parts separately, on their own. Let's just say on their own. Right? We want to, and the reason why we need to do it on their own is because we have to take all of the real numbers, add them together themselves. And we have to take all the imaginary numbers and add them together all on their own. Then we can combine everything together into one complex number. And let's see how we do that. Now I want to write 6 plus 3i minus 4 minus I as a complex number in standard form. So here's what we do. We look at our numbers and we say, okay, well, I have this real part 6, this real part 4. I have this imaginary part 3i, and this imaginary part negative 3i. Now I have to add, or I have to combine the 6 and the 4. What I'm actually doing is subtracting. You'll notice that's a subtraction symbol. So in this case, I'm going to subtract 6 minus 4. And I'll just write 6 minus 4. And I need to subtract the real part, or the imaginary part on its own. So I need to subtract 3i minus negative I. Right? This is negative I, so we're subtracting negative I. Now what we're actually doing is we have to put a plus in here, and just for a moment I want to take a second here. It doesn't matter what operation we're doing on the complex numbers. Okay, it doesn't matter if we're adding or subtracting. When we get to this stage, this should always be a plus sign, always. So don't worry about the fact that I'm subtracting here and I end up with a plus there. It's always going to be a plus sign there when I'm adding or subtracting. That's just across the board. Now, let's subtract the real parts and the imaginary parts on their own. So I have 6 minus 4, that's the real part, and that's 2. Have that plus sign. I have 3 minus negative I, well that's the same thing as 3 plus I. The imaginary part on its own is 4i. So when I combine them, just like combining like terms, really, I end up with 2 plus 4i. Same thing with addition. Same basic idea. We have a real part 2, a real part 7. We have an imaginary part 5i and an imaginary part negative 2i. Now we're adding here, so we need to add the imaginary parts together, and we need to add the real parts together. The real part 2 and 7, the imaginary parts 5 and negative 2, 5i and negative 2i. And we're going to do them separately on their own. So I'm going to add 2 plus 7. Notice that I have 2 and 7, right? It's positive this time. We're adding 2 and 7. And I'm going to add 5i plus negative 2i. Right? And again, it doesn't matter that this is plus in the middle here. The sign in between these two is always going to be plus. So We just don't even need to worry about it. Alright, 2 plus 7 is 9. We know that. 5i plus negative 2i is 3i. That means that when I add 2 plus 5i plus 7 minus 2i, I get 9 plus 3i. Again, just like combining like terms, really. It's just we have an I instead of an X.